Greetings to you all. In this video we will discuss about the determination of Young's modulus by non-uniform bending method. See, this is your aim. So you are finding the Young's modulus of the given material bar by non-uniform bending using pin and microscope method. In this experiment, the theory is already we have discussed in our theoretical part. Straight away we will go for the procedure. See, this is your experimental setup. You are arranging the knife edge at the two ends marked A and B. Distance between the two knife edges is denoted by L. You are fixing the pin and load over here. Look at the tabulation. We are measuring the distance between two knife edges L, and the least count of the traveling microscope is 0.001 centimeter, and the load value initiated from W indicating that the weight hanger. You are connecting the weight hanger in this apparatus, no? This is your W, and you are adding the load 50 by 50. So you are simply adding the 50 grams one by one. Whenever you are adding the load, it will decrease the height. That is called depression. See, you are adding the load in the middle. So one by one you are adding the load. Automatically what will happen? It will decrease the height. That is called depression. Okay. So you are measuring for each and every value of W, and W plus 50, W plus 100, W plus 150, W plus 200. In each and every case you have to measure main scale reading and vernier scale coincidence total reading. For loading as well as unloading you have to measure. So W plus 50, W plus 100, W plus 150, W plus 200 you are measuring, no? Then the same reading is applied over here, but one by one you are removing the load, then again you are measuring the microscope reading. Average between these two is measured and written as a mean. If you are interested to calculate the depression for mass 50 gram or 100 gram or 150 gram, whatever may be, you fix the M value. If suppose you are fixing the M value equivalent to 100 grams, what you have to do? You have to make a difference from W and W plus 100, W plus 50 and W plus 150, W plus 100 and W plus 200. Make a difference between these two alternate values, then write it here. You will get 3 values only here. Remaining 2 you just put a dash and then calculate the average. This is your depression Y. Thickness, determination of a thickness. So here we are fixing the thickness in that virtual lab. But usually what we will do, we will use the screw gauge for measuring the thickness. Already we have uploaded the video for measurement of a thickness using a screw gauge and measurement of a breadth using a vernier caliper. If you are using a screw gauge, you can measure a thickness. Initially you have to measure pitch scale reading, then head scale coincidence, and observed reading you have to measure. But in our experiment, thickness as well as breadth, both values are fixed in the virtual lab. Now if you are knowing the values of M, L, G, B, D and also small y, we can calculate the Young's modulus value. Now we will go for the virtual lab, then again I will explain the calculation. Okay, see, acceleration due to gravity is fixed one, that is g is equal to 9.8 meter per second squared for earth, and we are choosing the material as wood. Okay, so usually we will calculate the Young's modulus for the wood, so we are considering wood. Then we are fixing the breadth of the bar, let it be 3 centimeter, and the thickness of the bar, let it be 0.6 centimeter. So here we are fixing the breadth of the bar is 3 centimeter and the thickness of the bar is 0.6 centimeter, and also we will fix the knife edge distance, let it be 60 centimeter. Look at the adjustment here, you have a adjustment like this. Okay, this is for L is equivalent to 60 and B is equivalent to 3 centimeter and D is equivalent to 0.6 centimeter. Now we are fixing the value 50 gram. So how you will measure a reading is just to see here, the right side scales are said to be main scale reading, left side scale is vernier scale reading. In vernier scale you have a 50 divisions. In the 50 divisions, 0 is indicating the MSR reading. So in this case, what is your MSR reading? 5 unit. So if suppose correspondingly it is showing the 5 means you try to take 4.95. So the previous reading we can consider. Okay, so it is not exactly showing 5. Small amount of variation is lesser than that of 5, so we can consider it as a 4.95 is your MSR reading. Among the 50 divisions, which one is coinciding with the main scale, that we will check it. So in this scale, if you are checking means, see 49th line is coinciding. So what is the solution? MSR reading is 4.95, 49 is coinciding. This is your VSC reading. Okay, now again what you are doing, you are going for the next load 100 grams. 100 gram means again you just check it. See, you will get 5 units. Again the coincidence may vary, so you will get some other coincidence. Say for example, you will get 48 is coinciding. Then similarly 150, 200, this is your 200, this is your 250 and 300. Like that we can measure the value. So in each and every case, while enlarging it is showing the same display, but the measuring methodology I am telling. So each and every time if you are increasing the reading, automatically what will happen? In nature it will decrease the height. So here while enlarging I am explaining how you have to select a reading, that only I am explaining. Okay, so for 0 is indicating the value of 5 means the MSR reading is equivalent to 4.95 and the vernier scale coincidence you have to measure. Okay, so after the measurement, if you are calculating the value, okay, you will get the Young's modulus value equivalent to 1.1 into 10 power 10. See, I will show you the formula. So this is your formula. In this case the depression M, let it be 100 grams, so 100 into 10 power minus 3 kilogram, and let L is equivalent to 60 into 10 power minus 2, that we have fixed in the virtual apparatus. And acceleration due to gravity G is equivalent to 9.8 and breadth in B is equivalent to breadth is equal to 3 centimeters, so 3 into 10 power minus 2. Thickness D is equal to 0.6 millimeter or 6 millimeter. You will get 0.6 into 10 power minus 2 meter or 6 millimeter. 6 into 10 power minus 3 meter. So it's your wish, you can write in millimeter or centimeter, but finally you have to convert it into meter. That's why I am telling. So 6 into 10 power minus 3 meter or 0.6 into 10 power minus 2 meter. So the measured value may be millimeter or centimeter, but while substituting you have to produce in terms of a meter. Okay, then you are substituting all the values in E. You will get, in the formula you are substituting mgl divided by 4 bd cube y. Y is a depression value. So if you are substituting the depression value, you will get the Young's modulus of a given material. Okay, thank you.